Hello, algebra students. We're going to continue working with inequalities today. Today we're going to be solving inequalities and graphing solutions on a number line. So I'm going to share the screen and I'm going to put up their presentation. You will need your student journal today. All right, and first you should take out some paper and try these warm-up problems. So go ahead, grab a piece of paper, pause the video, and give each one of these problems a try. All right, welcome back. So we're supposed to define a variable and write an inequality for each situation. So the first one says, a speed that violates the law is anything over 70 miles per hour. So I'm going to use the variable, let me grab a pen here. I'm just going to use the variable x to represent the speed. And it says a speed that violates the law is anything over 70 miles per hour. So that would be x is greater than 70. So notice I did not put greater than or equal to, because if I'm going 70 miles an hour, if my speed is equal to 70, I'm not breaking the law. So I don't break the law until like, oh, over 70, 71, 75, 100, all of those are greater than 70, and that would be breaking the law. All right, number 2 says, a person needs to be at least 21 years of age to purchase alcohol in the US. So I'm going to use the variable a to represent age. And it says a person needs to be at least 21. So I know they have to be older than 21. Can they be 21 and purchase alcohol? Yes. So if their age is equal to 21 or it's greater than 21, they can purchase alcohol. All right, number 3, a school bus, I'm going to use B for bus, can seat at most 66 students. So I'm getting on the bus. There's room for 66, so the number of students that get on there need to be less than, or it could be 66. It says the most we could have is 66. All right, let's look at the next slide. You have a vocabulary term that you need to write down in your journal on page 35, so pause the video and write down the definition of equivalent inequalities. All right, we also have some core concepts today. Those are also in your journal. Addition and subtraction properties of equality. They're very much like addition, subtraction properties of equality, where as long as you do the same thing to both sides of an inequality, you don't change it, right? It keeps it balanced. All right, let's look at some examples. These are in your journal. Extra practice problems on page 36. So it says, solve the inequality and graph the solution. So on this first one, I'm going to solve it. Again, I'm trying to get the variable isolated. So in this case, I'm going to start by adding 3 to both sides. That leaves me with x is less than, all right, these 3's are gone, -4 plus 3 is -1. All right, so I go over to my number line. The important number I'm going to need on that is -1. I just need to put a few numbers on the number line. I'm going to do some both directions. Okay. Now it says x is less than or equal to -1. So things that are less than -1 would be like -20, -5, -1 is less than. So anything over on this side to the left of -1 is going to be in the solution. So notice there's no equal sign, which means I put, and we talked about this last lesson, I put an open circle on -1, and my solutions are anything that goes to the left of -1 on the number line. So anything over here. Right. Question number 2. This time my variable's on the right, so I'm going to leave it on the right. I'm going to isolate it by first adding 3 to both sides. So on the left, -3 plus 3 is 0 is greater than these 3 cancel, and I have H. So this says 0 is bigger than H, or 0 is bigger than any number I'm looking for. All right, so that's the biggest thing it's going to be. So I'm going to make my number line. I know 0 is important, so I want to make sure that's on there. And again, I'm doing a few numbers to the left and to the right. All right, looks like open circle at 0, right, because it can't be equal to it. And it says 0 is the biggest number, right? So things that are smaller than 0 would be things like -3, -2, -1, anything on this side. So again, my arrow in this case is also going to the left. So you need to be careful when you're working with inequalities. A lot of times people think that, well, this arrow here on the inequality is pointing to the direction of the arrow, which it was on number 1, but on problem number 2, the inequality pointed to the right, but our solutions were to the left. So make sure you're reading the inequality correctly. This says 0 is greater than H. So 0 is greater than any of the solutions. All right, let's look at some more. This time we have, looks like we need to combine some like terms here before we solve. So we have 6 minus 9, that would be -3, plus u is less than -2. All right, so I'm going to keep solving. I have my inequality on the left. I'm going to add 3 to both sides to keep it by itself. So that leaves me with u is less than, and -2 plus 3 is 1. All right, put a few numbers on the number line. And this time, we have that u is less than or equal to 1. So I'm going to make a closed circle or a closed dot at 1. And I'm looking for numbers that are less than 1. So things that are less than 1 are things like 0 and -3 and all those numbers that are to the left. So my solution is anything going to the left. And I put an arrow on the end to indicate that it's all of the numbers forever to the left. Okay, it's that line is going forever. All right, number 15, also have some like terms again. I'm going to start by combining these c's. 4c minus 3c leaves us with 1c plus 10. And that is greater than or equal to 12, or 12 is less than or equal to c plus 10. Again, I'm trying to get the variable by itself, so I'm going to subtract 10 from both sides. That leaves me with 2 is less than or equal to c, all right, or c is greater than or equal to 2. I'm going to put some numbers on the number line. Oh, I went all the way to 4 that time. That's exciting. All right, so this time 2 is the number I'm focusing on. It says that c is greater than or equal to, so I fill in the dot. And this time 2 is smaller than anything else, right? My solutions are anything bigger than 2, so all the things to the right. So any number to the right of 2 is in the solution. Again, I'm going to put an arrow to show that the solutions are anything this direction forever. All right, next. We have some word problems. Let me move this out of the way so you can see. It says you have $15 to spend on groceries. You have $12.25 worth of groceries already in your cart. And part A says, write an inequality that represents how much more money M you can spend on groceries. All right, well, I know I have $15. So I know I have to have it. Oh, let's go back. I forgot to have my pen. I know I have to have less than $15, right? I don't have any more money. All right, could I spend exactly $15? Sure. All right, so what I spend has to be less than or equal to $15. Well, I have already spent, let's see here, $12.25. So I've spent $12.25. I have M more dollars or more money that I can spend. So my $12.25 plus whatever else I spend has to be less than or equal to $15. All All right, and then it says to solve it. So I'm going to rewrite the inequality down here. All right, I'm going to subtract 12.25 from both sides. And it's not looking like I have a whole lot more to spend on groceries. This maybe is just like a snack run. We have M is less than or equal to, and 15 minus $12.25 is 2, oop, that's a 7. All right, so I have $2.75 more to spend. All right. Let's look at our next slide. And our next slide is the assignment. So it's 2.2, page 65 in the textbook, and you're to do problems 7 to 29 odd. On today's agenda, I have included the pages from the textbook. There's a link that you'll find. If you go into Schoology, click on today's agenda, and you can complete the assignment. Thanks, good luck.